Okay, thank you very much. Everybody hear me okay? All right. So yes, as Paul mentioned, we're going to talk about severe weather forecasting, not necessarily the nuts and bolts as in like all the weather data we dive into, but when you get a tornado watch, who do you get it from? How involved are we in that process? Severe weather forecasting a little bit in that process, and some of the reporting and how to get us the information that we're really looking for to make warning decisions. Okay, so again, a little bit about the National Weather Service, just a reminder of who we are, your Nashville local office. We'll talk some about that. We'll talk about the role of the Storm Prediction Center, that's a national center within the Weather Service, and how they interact with our smaller local offices. We'll talk a little bit about severe weather forecasting, how that gets to watches, warnings. I guess I'm really excited to talk about watches, warnings, and advisories because I got it on there twice, and then reporting to the Weather Service. Okay, so how many of you are pretty familiar with the Weather Service? Okay, so we have some that aren't. That's good. That's good. So we'll talk about us a little bit. We are a federal government agency. We are buried under the Department of Commerce in the National Oceanic and Atmospheric Administration, or NOAA. Our agency consists of 122 small offices, just like ours here in Nashville. Some of the other ones that serve Tennessee include Memphis, Knoxville, or Morristown, and then Huntsville, Alabama sneaks in for Lincoln, Moore, and Franklin counties in southern Middle Tennessee. We have about 4,800 employees, and then we have national centers too. So I'm guessing several of you are familiar with the National Hurricane Center. That's a national center down in Miami. They do the 5-day cone that you see all over the media. They're the ones that do that. Storm Prediction Center, they handle the watches. Climate Prediction Center, you've probably seen those graphics on our Facebook of the 6 to 10 day and the 8 to 14 day outlooks showing the odds favoring well below normal temperatures. You can thank them for that bad news recently for the upcoming cold. We have river forecast centers. Our nearest one is in southern Ohio that takes care of the Ohio River, Tennessee River, aviation units, National Water Center. They're real big into flooding. They're in Tuscaloosa. So that's a little bit about us. Now, our local office, we have about 22 when we're fully staffed, 15, 16 of which are all meteorologists, so we can work shifts, we can issue warnings. In fact, that's probably our biggest duty is the issuance of watches, warnings, and advisories. We're the sole entity that can issue official watch, warning, advisory products. So anytime you see the scroll at the bottom of your favorite news channel, that's us sending that out. Wireless emergency alerts. If you get a tornado warning, that starts with us and goes through the process of distribution. Some other private weather companies can issue warnings, but that is a paid service for corporations, stadiums, things like that. So we're the only ones that do it publicly. Again, aviation forecasts. Reason we're under the Department of Commerce is think of how many things in our economy are affected by weather. Okay, Hurricane Helene, how many roadways were closed because of all the flooding? All right, so there's one aspect. Aviation, anytime, how about this morning, there's low clouds, maybe some fog, cooler temperatures aloft, so maybe they're dealing with some icing concerns. There's weather, and even if it's just fog and stratus, they have to spread out their planes and reduce the amount of planes in and out of the airport for safety because the tower can't see them. So they're relying solely on instruments, and that triggers other things. River and flood information and forecasts, that's us. Maintain external and internal equipment. We utilize a ton of computers, servers, communication networks. Our radar there at our office has to be maintained and working 24/7. We conduct community outreach, so hello. That's one of the reasons why I'm here, and we do other things like spotter talks and school talks and safety talks and planning, preparedness talks. Another big thing that we're really going into is provide expert advice to emergency operations centers or emergency management. This is what we call decision support services. So instead of just packaging our forecast and saying, here's what we got, now we're adding that interpretive service, that value added. So, okay, here's what that means. So a low temperature of 32 in January, no big deal, right? A low temperature of 30 or 32 in May, once the growing season has started, that's a big deal. So highlighting those kind of things that, you know, may warrant some action or some planning, things to do, that's where we come in. Our biggest thing is working large events right now. So, for example, when Davidson County or Metro Nashville Emergency Management contacts us and says, hey, we have a big concert or a Titans game or CMA Fest. We'd like you to come out because we know there's storm potential and you can be there working with us for lightning and planning. We go out for that. So that's a little bit about us locally. In terms of our staffing structure, again, 6 lead meteorologists. That's new. It was 5 for years and years and years. But the Weather Service has added a lead meteorologist at every office. Helps a little with the shift flexibility, giving them opportunities to work more events like this. Otherwise, they're always on shift and that's all they do. What else? 7 meteorologists, 2 electronic technicians, plus a manager for electronic systems. Again, I'm the warning coordination meteorologist. I'm your main outreach, media contact, just the public-facing side. So you may have seen me on, I was talking to Alex Libby of WKRN this past week about the upcoming cold and explaining what our cold products mean. So if you see a cold weather advisory, you know, now you may know what that entails. We do have a service hydrologist at this office because of our major river systems. In the flooding that we can get. So he works a lot with things such as flood inundation mapping. That's a new thing we're doing, or working with the Ohio River Forecast Center to make sure those flood warnings are good. Now, to be a member of our team, this goes into severe weather forecasting. I think one of the questions Paul provided me with is, who can work radar? Who can issue those warnings? Well, we all have to go through a lot of training to be able to do that. First, we must have a 4-year degree in meteorology or atmospheric science. We have to have 9 hours of physics, 6 hours of calculus, then differential equations, thermodynamics, dynamics, all these different kinds of courses to be able to work for the National Weather Service. Then once we're in, that doesn't mean we can just issue warnings from day one. No, we have a lot of training to go through. All of us must attend a radar and applications course. That entails hours and hours and hours of online modules going through the environment and severe weather forecasting and radar and all the ins and outs and technical aspects of that radar data that we're looking at. We have to know all the background information. Then as we're going through our training, we're doing simulations. So we have to go sit in our training room for 3 hours and we can issue practice warnings and work through scenarios and learn. Then after we've done all this training, now we get to go to Norman, Oklahoma for a week at the Warning Decision Training. I can't remember the full acronym right now. But we have to go there for a week, and that's just a week of simulations. So it's weather events that we've archived data from many different severe weather, flash flooding, a mix of both type events. They throw us the normal stuff like your classic plain supercell that is just one at a time, to, hey, how about a Middle Tennessee event where you have 10 of these plus a line plus flash flooding. So it's very intense. I remember sitting in the lobby a couple times after this week, after a day of training, and just thinking like, my mind is numb. I can't do anymore right now. So they really put us through the ringer in that one. After that, then we must go do a couple more training courses to further our radar skills. We have annual training refreshers done locally, so depending on our needs and our ones that we want to address. If we're newer to radar, we may be shadowed by someone. And once we go through all this, then we're able to be cut loose and do warnings on our own. So when we say we're highly trained, we are going through a lot to make sure that we are providing you with the best warnings based on all the information we know how to analyze as we can. Okay, so during a severe weather event, what do? We do a lot. A lot. Not only do we have our routine duties that we must continue, so the 7-day forecast, our aviation forecast, maintaining the climate information. We will launch a balloon twice a day. Right now it's 0Z and 12Z, so that's the balloon goes up at 5 a.m. and 5 p.m. We launch an hour before. We have a window, hour before to 30 minutes after, to get that balloon up. That way, in case there's a failure, we can try again. So we have our routine duties, but then we have all our severe weather duties. So watches, warnings, advisories, any flood analysis, communication, decision support services, coordination with our emergency management and broadcast media to make sure those messages are flowing, the messages that we want. Social media, all this builds up. So we staff up and staff down for severe weather. So on a routine day, like today, we may only have 2 people there, sometimes 1, if there's really nothing going on. But then when severe weather happens, it depends on the event. If we're expecting maybe a couple pop-up showers and thunderstorms, one or two of which could become severe, we may only have 3 people there. If it's a day like May 9th or May 8th and 9th of this past year, or December 9th of 2023, some of our other major events, we may have 9 or 10 on that ops floor at a time to handle the workload. We may have, I think on May 8th that evening, when we had our Columbia tornado, I think we had 3 radar operators going at one time because there were so many storms. So it was quite the workload there. Here's kind of what our office looks like. Again, one person may have one role, and usually that's just radar. If you're on radar, you are just radar. You're not doing anything else other than maybe a little mesoanalysis or looking into the environment to make sure, okay, yes, it makes sense to continue this tornado warning. Everything's good to go. Some of us, though, may have multiple roles. So, for example, one role I usually take is like communications. So that can be NWS Chat, our internal chat service that some of you are on to share reports, share messages with the media, work with emergency management to get the latest. I also do social media, phones. I text our emergency managers if there's something big coming their way. So, for example, on May 8th, I was texting Murray County, and the storm looked really good through Lewis and Northern Lawrence and Perry. I was texting all them like, this could produce a tornado at any time, to give them that heads up as much as I could for that situation. Staffing decisions made a few days in advance. Again, weather dictates some of those situations or decisions, and then we play to everybody's strengths. So if we have someone that's really into social media and wants to do social media, great, you can do social media. But we do also try to share opportunities. So maybe if someone hasn't worked radar as much, we do all still work radar at some point, but maybe they want to jump in and say, hey, I want to do severes for this particular event. We give people experiences. Okay, so that's a little bit about local operations. Any questions on local operations? Okay, Let's talk about national operations. The Storm Prediction Center. They are located in Norman, Oklahoma. They've been there since 1997. This is our big National Weather Center. There's a lot here. In this building, there's University of Oklahoma. Their School of Meteorology is there. There's the National Severe Storms Laboratory. So they're the ones that whenever you turn on the news coverage of tornado outbreaks in the plains and they show you the Doppler on wheels, that's them. They're a heavy research branch. The Warning Decision Training Division, there's that acronym that I missed earlier. That's where we go to do our radar simulations. The Forecast Office in Norman, Oklahoma, watching most of central Oklahoma, is there. Now, outside of this building, there's many other structures, and that hosts like private weather companies. So there's that collaboration between government and business and the School of Meteorology. It's a very intense weather area there. Originally, they were based in Kansas City. They were known as the Severe Local Storm Warning Center, or CELS. They originally started in 1952, then they settled in Kansas City in 54, then moved to Norman, Oklahoma. There's two branches. The operations, those are the products we see. So the outlooks, the watches, a few other things that I'll get into shortly. And then there's the science support. So IT, as well as bringing the latest research into operations so it can be applied for us to provide better forecasts to you. So what are their duties? I took this straight from their webpage. This is what their operations area looks like. They, like us, have 3, maybe 4 people always on watch scheduled there. But their goal is timely and accurate forecast and watches for severe thunderstorms and tornadoes across the U.S. They also monitor hazardous winter weather and fire weather events across the U.S. and issue specific products for those hazards. So that may be a little bit of a surprise. You thought they were only thunderstorm heavy, but they also do winter weather and fire weather products. So here's probably what you're familiar with, the convective outlooks. These are the ones that they are issuing from Norman, Oklahoma. They take in all the data. They're looking at the instability, the wind shear, the moisture, the front timing. They're looking at previous night storms and how that may interact with the storms that are forecast. So they take in all that data and then they draw these maps where they think thunderstorms are most likely. These maps, the different shading, means the probability of severe weather within 25 miles of a point. So for example, a moderate risk, let's see, that's towards the bottom there, that pink, that's a 45% chance of a severe report within 25 miles of your point, okay? So basically that's saying there's a very good chance in your area that we're gonna have damaging winds, large hail. Whenever you see the black hatching on those bottom graphics there, that means a chance for significant severe weather. So for winds, we're talking 75 miles per hour or higher. For hail, we're talking 2 inches or higher. And tornadoes, that's EF2 or higher tornadoes. So a more significant event. This is the outlook for our May 8th into the morning of May 9th outlook. These outlooks go from, depending on the time of year, when it's daylight time, when most of these outlooks are, it's 7 a.m. to 7 a.m. is the valid time for this outlook. And then you can go in and read the technical discussion of what we're expecting and why. Now, locally, it may look more like, on the right there. This is a statewide briefing that we do for Tennessee Emergency Management Agency, or TEMA. This is how we repackage these Storm Prediction Center outlooks and share that information locally. So the Storm Prediction Center may just say, we're expecting storms to move across the middle of the U.S. today. Well, we repackage that to TEMA and our emergency management and say, for Middle Tennessee, it's going to be after midnight. So that way they're not waiting during the evening like, where is it? Where is it? We've told them it's going to be overnight tonight. And we adjust the threats a little bit to highlight what we're thinking here. SPC is thinking nationally, we're thinking local, and really honing in the fine details for our local people here. Another big thing they do is mesoscale discussions. They do these type of discussions at various points within the severe weather day. So these are day of discussions, maybe valid for only 2 to 4 hours. So the one in the top left there, it talks about we're needing a tornado watch, and in fact a particularly dangerous situation tornado watch within 2 hours, because we're expecting storms to develop rapidly, quickly becoming tornadic. On the bottom left there, that's a watch update. So we can, they'll do discussions on here's how things are progressing, are the threats changing any timing information. That's another discussion they can do. Another one to the top right, they have a hatching there in the middle that says long track high-end tornadoes possible for the next couple hours. So that's really amplifying their message. That gets the attention of us locally. That gets the attention of the media. And then finally, sometimes in the bottom right there, they'll do a discussion for individual storms. So this was for a storm on March 31st that produced 2, 3 EF3 tornadoes across Arkansas into western Tennessee. Very potent storm. I believe this one produced a tornado in Little Rock area as well. So, they really honed in on that storm and focusing on that. The reason they're doing that is mesoanalysis. Again, watching that moisture, instability, wind shear, and these storms evolve, right? Like our May 8th storm that hit Columbia, it wasn't a supercell that much longer. And so that could have been SPC's opportunity to say, we're expecting this to morph into a storm, likely producing significant damaging winds over the next 2 hours. So that's the kind of information they're trying to do. They can't do that for every supercell thunderstorm. Generally it's a quiet day, or it's got to be a very high-end day for them to do that. Otherwise, we're handling that locally with our messaging a lot of times. They are the ones to issue the convective watches. So severe thunderstorm tornado watches, they're the ones that push the button to send that information out to you. It makes your weather radios go off. It makes your county alerting apps and reverse 911 or whatever you have go off. It makes all your weather apps go off. So they're the ones that do this. Now, we do send these locally, and we can have a say in these watches locally, but they're the ones that press the final button to distribute that. They can also issue convective watches, kind of like we have tornado emergencies, we have flash flood emergencies that can set off wireless emergency alerts again. They have convective watches that they can add in particularly dangerous situation wording in there, so they can really amplify this is going to be an extreme tornado outbreak. April 27, 2011 is one that comes to mind. That March 31st event that hit West Tennessee so hard, that was one of those type of days. In terms of particularly dangerous situation, I'm trying to think the last time we had one of those in Middle Tennessee. I'm not sure. It may have been March 31st. They can do it for severe thunderstorm watches. That's mainly for those type of events that we call derecho, or a long-lived windstorm that'll produce high-end winds, so 75 plus miles an hour for over 200 miles. That's the type of event. So when Iowa was devastated in, was that 2020? They were having reports of 140 mile per hour wind gust. That's equivalent to an EF3 tornado. Multiply that by 20 miles, and that's the kind of event they were expecting out there. So these are the type of events that particularly dangerous situation watches are covering. Now, they can do mesoscale discussions for winter weather. So mainly they're focused on precipitation types and transitions. In this case, this was taken recently, January 9th, across Texas, barely clipping Oklahoma and Arkansas. It's talking about freezing rain, perhaps some sleet, snow mix through this morning. So they can highlight that because they're monitoring all the mesoscale data, so they might as well write a little discussion about it while they're at it. Again, we're doing that locally because we're having to make decisions too, but they help out with that as well. Here's another one across Kansas recently with the blizzard that hit them so hard. Talking about we're having some freezing rain at this time, but expect the blizzard to ramp up. This is another tool, not just, okay, so SPC's customers, they're a national entity. They work a lot with media, like more national media, and then FEMA, whereas us locally, we're working with our local media. But the local media certainly follow SPC. Like they're watching it. They see it pop up in our chat service, so they read all the products as well. But again, just another tool to help us stay abreast of the evolving weather situations. Fire outlooks. That's an image from the Palisades fire recently in California. And the Storm Prediction Center does fire weather outlooks. They have a desk dedicated to fire weather to serve our fire partners and provide that outlook, that national situational awareness. In fact, you see there right in the middle, a dangerous fire weather event is currently unfolding in portions of Southern California. They had a area highlighted. It's difficult to see, but it's pink, which is their extreme threshold. That's the highest of the high for that Santa Ana wind and fire event. But this is another thing they do that can help us and can help our partners. So how do we interact? First of all, both of our groups are experts. We have our niches, though. Again, SPC is national scale in their forecast. Our office and the other 121 offices that we have in our agency, we focus local. So we know the terrain. We know how the terrain interacts with storms and weakens them or enhances them, whatever it may be. SPC lives and breathes severe weather, but they also dabble in fire and winter weather. Their stakeholders, again, are national partners, and they provide expert advice to not only just local offices, but emergency management and media. Their primary audience is not the general public, but certainly those outlooks do get to the general public. Most of the time that's repurposed through the local offices saying, here's what we can expect here, and we really hone in that map to our local scale. Our local office, we focus on all types of weather, and we're experts for Middle Tennessee, or we're experts for West Tennessee. Our stakeholders are local and state partners, so EMAs and TEMA, local and regional media, departments of transportation, health departments, city and community officials. You are our customers locally. Again, we also provide that decision support services using SPC forecasting, advice, information, and we interpret that for our local people. So how does it look like when we're working on these convective outlooks? Does your local office have a say on those? Yes. Yes, we do. It's not just SPC giving it to us on a platter and saying, here you go, and then the WFO, our local office is like, oh, this is great, or, oh man, this is terrible. This is not what we were thinking. We do have the opportunity to discuss that outlook, and there are windows to collaborate ahead of that outlook release. Sometimes it's a little bit of a surprise. Most of the time it's not. So again, we're all looking at the same data. We have our different focuses, but we chat on an internet internal service on our computer system. So this chat service is only in the weather service. This isn't NWS chat like some of you may have an account for. This is internal, and we're chatting, and and it kind of looks like AIM back in the day, if you remember that. It kind of looks like that. So we can chat SPC, hey, what are you thinking for tomorrow's day one outlook? I'm looking at the latest data. We're looking at our weather balloon that was just released, and we think it's going to be a potentially significant event. Can we ramp up the wording? Can we ramp up the outlook? We can do things like that. The two convective outlooks shown here, that's our March 3rd, 2020 tornado event. We could have had a say in expanding that to the east. As you know, that event produced the Cookeville tornado. I believe that was just in the marginal area when it happened. So marginal risk for severe weather, that's generally 5%. So you wouldn't expect a F4 tornado to happen in that type of situation, but I know that day there was uncertainty on how far east the instability would get. And so another thing with these outlooks is we can do updates. So as it becomes more certain of, hey, this instability is going to be further east, we can drag that outlook east and update that product. When it comes to watches, the way it works is SPC sends out a notification. Usually we've chatted on that chat service ahead of time of, hey, we might need a watch by 1 p.m., okay? So then when that time's coming, the instability's building, the wind shear's improving, maybe on satellite imagery, we're starting to see those towering cumulus, so before the storms. SPC sends a notification to us. We all jump on a conference call. We see the proposed watch from the Storm Prediction Center in Norman, and that's our opportunity to say, hey, I think that looks great for my area. Can we add a few counties on the east side? Or the storms have already passed this area. We don't think that we need to watch for these counties because by the time we get it out 10, 15 minutes later, the event's going to be done. We can talk about the type of watch. So maybe watch warning, or not watch warning. We can talk about tornado watch, severe thunderstorm watch. So these are the things that we talk about with SPC on these conference calls. Once we all agree on the type, and that also includes the regular tornado watch or particularly dangerous situation tornado watch. Once we all agree on this, we hang up the phone, SPC sends it out, then we send it locally. So that's how that collaboration works. So we do have a say on these watches and what we get as a result here in Middle Tennessee. During the watch period, SPC and your local office, we remain in contact. And we update these watches. So the watch goes out, we don't just let it sit there for 6 to 8 hours, especially as the storms progress across the watch area. We start trimming on the backside of it and get the counties out of there that no longer to be on that watch status. So as conditions and storms progress, we adjust. The local office is the one that makes adjustments to the watch. It's not Storm Prediction Center because as you saw for that watch here, those red and black X's, that's 7 offices that the Storm Prediction Center may have to collaborate with on this watch. Now, on a severe weather day, you may have 6, 7 watches out at one time, so that means the Storm Prediction Center has to work with 45 plus offices potentially. That's why local offices take care of the watch updates. So what we do, we go in and cancel counties on the back. We may cancel the watch altogether if it just looks like a heavy rain event, our instability is kaput, let's get rid of the watch. So the local office is the one that makes those adjustments. We have to do that between 10 till and 10 after the hour, and then it makes the national map and into the Storm Prediction Center updates. We usually talk about this on that chat service. Sometimes maybe we might pick up that phone. A lot of us meteorologists can be a little introverted and not want to pick up the phone and talk. So that's why I put maybe on there. It depends. Okay, so again, here's kind of how things go. We have our discussion. The Storm Prediction Center is discussing it. We're discussing it locally in our area forecast discussion. Then we get to the outlook stage. On the day of, we get to the watches. Again, that's 4 to 6 hours in advance. And then locally is where you get your warnings. So the watch from Storm Prediction Center, the warnings are local. So what's the difference between a watch and a warning? Maybe it's because I'm hungry and thinking of breakfast. I don't know. But watches and warnings. A watch means all the ingredients are there. Sometimes you already have storms going. We try to get these watches out before the storms get going. So we have all the ingredients. We have the lettuce, tomato, cheese, pickles, bun, hamburger. It's all there and ready to go. It just requires that spark to get it going. Once we get that storm or that hamburger going, now we issue the warning. Now we have confidence, it's there. We're gonna have 60 plus mile an hour winds, quarter size hail, a tornado, whatever it may be, we're gonna have that within this polygon that we draw, okay? So a watch usually lasts 3 to 6 hours. This means conditions are favorable. We can issue watches. Storm Prediction Center takes care of tornado, severe thunderstorm watches. We take care of flash flood. The severe thunderstorm tornado watches are the only ones issued nationally that you'll see here, okay? The National Hurricane Center takes care of hurricane watches, storm surge watches, warnings. They're the ones that do that. The Water Prediction Center, which does a lot of the snow forecasts, the liquid amounts that you see, QPF, they take care of the forecasts. And there's talk maybe one day they get winter storm watches, but for now they don't have watch responsibility. But it's possible they could have flood and winter watches. But for now, Storm Prediction Center is the one that will get watches from nationally. When it comes to warnings, that is your local office. That is me. That is whoever at the office that's on shift that day pressing the button to issue those warnings. A watch covers regional areas, so it may cover parts of several states. It's going to cover multiple counties. Local, the warnings, those are going to be your polygons for individual storms in threat areas that we think is going to produce that severe weather. So what is the criteria for a watch? There's a little leeway here, okay? The hard and fast one that I could find on the website is an organized episode of 1-inch hail or larger, damaging winds of 58 is the technical definition, so we'll say 60 miles per hour or higher, and or tornadoes expected during a 2 to 8 hour time frame. But this varies. We don't have to have a watch out for every warning. We don't try to do that. If we think it's an isolated storm that's just going to produce some marginal severe weather, like quarter-size hail for the next 2 hours, we may say, hey, let's not mess with the watch. Because we can handle that messaging locally. We can put a graphic on social media that shows on the I-40 corridor next 2 hours, including the Nashville Metro, we're expecting a storm to produce some hail. Okay, we can handle that same type of message locally. And in our NWS chat service, we're talking with our media. Hey, here's what we're expecting. We're not going to have a watch, but here's how we're going to message it. So they try to keep the watches to an event where you have more severe weather reports, not 1 or 2. We're talking 20 or more that we're aiming for to have these watches out. They are issued as conditions become favorable or storms start forming, or sometimes we realize, hey, this is bigger than we thought. We need to watch out for the counties downstream. Typical watch covers 25,000 square miles, or half the size of Iowa. Again, these are county-based. So you're not going to have half your county in a watch ever. It's all or nothing. A warning is issued when we have 80% confidence that we will have severe weather. 80%. So that's going to be hail quarter size or larger. That's going to be winds of 58 or 60 miles per hour higher. That's our severe thunderstorm criteria. A tornado does also qualify a severe thunderstorm. We like to have tornado warnings with our tornadoes, but sometimes it's that line of storms. You may have 5 or 6 circulations on the leading edge of that line, and choosing which one's going to produce that 2-minute tornado can be difficult at times. Usually that's a lower end tornado threat. It's not your EF3s and EF4s that wipe your house off foundations. So a tornado does classify or go into severe thunderstorms, but we like to have tornado warnings out for tornadoes. Again, these are your polygon-based shapes. They depend on the storm, the situation, the threat, the geography, county lines. If there's a storm coming in from the west and Williamson County is not even going to see rain for 45 minutes, I'm not going to include Williamson County in that initial severe thunderstorm warning because your time will come. We'll try to get it out 15 minutes ahead of that storm entering the county. But we don't want to set all the bells and whistles out and say, hey, you still got an hour. We want it a little closer to time because people can get complacent. I worked the April 27, 2011 tornado outbreak in Memphis. We had an EF5 in our area, the Smithville, Mississippi EF5. I remember we were issuing tornado warnings so far in advance, and the storms were going 70 miles an hour. So these storms were on people quick, and we were issuing very large polygons. But I remember getting a call saying, hey, we just got a tornado warning. I'm in this town in Mississippi. How long do I have? And so I timed it out on radar, and I was like, you got about 40 minutes before that tornado circulation gets there. He's like, oh, okay, great. I've got time to run to the convenience store for cigarettes. No, that's not what we want you to do. But then at the same time I was thinking, I was like, well, it's kind of silly for me to tell you, run to your basement and stay there 40, 45 minutes. Usually we want these warnings for people to take more immediate action, not plan that out. So anyways, that's a little bit of how geography can impact your warnings. I don't want to say play games, but we plan out our warnings to try to account for. My ideal philosophy is you have one thunderstorm moving across your county, right? I want you to get one warning. I don't want you to get 3 or 4 because we don't clip on the county lines. Does that make sense? Okay. How many watches do we get a year? Here is the national climatology of severe thunderstorm and tornado watches per year. What do you know? Oklahoma's a hotbed, right? Severe weather central. However, I'm going to use this. How about this area in through here? There's a reason we call the Jackson office in Mississippi Action Jackson. They get a ton of severe weather, especially this time of year. A ton. In fact, they were just busy, end of December? That they were having large tornadoes. I think I saw at least 2 or 3 EF3s. So we get the wintertime activity. We can sometimes call it another tornado alley. There have been studies showing that severe weather has shifted more towards the southeast, but in the plains in the summer, it's hot, you have moisture, all you need is that trigger, which is your dry line or a cold front, and boom, you have conditions favorable. This is actually my previous office right there. So we dealt with a lot of severe weather there. In the summer months, we can shut off the severe weather. We lose the wind shear. So you may have more of your air mass thunderstorms that go up. Maybe they produce a downburst, some damaging winds, but most of them are just going to rain themselves out in an hour because they can't keep up that warm, moist air into the system. So here in Middle Tennessee, we average about 6 to 8 tornado watches per year, and we average about 6 to 8 severe thunderstorm watches per year. This is a 20-year average. You can really see that southern tornado alley showing up here. They get a lot of wintertime severe weather, and much more often than not, we'll just put out a tornado watch over a severe thunderstorm watch because they have the wind shear. That's the thing about these wintertime events. There's never a guess if I have wind shear or not. It's pretty much, I've always got it. The question in the winter is, do I have that instability? That was our question on December 9th. The wind shear was there. The question was, are we going to have enough sunlight, moisture, that warmth to really fuel these thunderstorms? And unfortunately, we did December 9th. We didn't realize that till probably a couple days out that, we might have a problem here. But sometimes, unfortunately, it's day of. Is that warm front going to move far enough north for us to get these storms in our area. So it can be very difficult. Here is what happened last year. We had a few more tornado watches than average last year across Middle Tennessee, 1 to 2 more. But a lot of the southeastern U.S. was below normal. 5, 6 tornado watches below normal. We are quite quiet last year. That is our El Nino type pattern. Usually severe season starts late because these low pressure systems are going along the Gulf Coast. Instead of like this year, well, once we're not under Arctic outbreaks, these low pressure systems should be going north of the Gulf Coast and even north of us, which puts us in that warm, unstable sector for severe storms. So I would expect a more active spring severe season, and it's not going to start in May. It's probably going to be more perhaps February if we ever warm up. Probably more March, April, May. We're going to see more of our traditional severe weather season. Could start early, but it could be frequent as well. So a little bit light on the severe watches and tornado watches last year because we did have a slow season. But as you remember, May was quite busy, and then we were pretty much done because we went into drought for June and July. So an interesting season last year, but residents in Columbia will definitely tell you, hey, it was a bad year. And all it takes is one, for that to totally change the story. But for most of us, I remember I was kind of tapping my foot in my first spring here, like, where is it? Where is it? I know southeastern United States has lots of severe weather this time of year. Where is it? And it just finally arrived in May, but that's your El Nino pattern. Climatology. Middle Tennessee has 140 to 160 days per year with thunderstorm risk. This isn't necessarily severe, okay? This is just thunderstorms. So lightning, gusty winds, heavy downpours, 140 to 160 days on average. Last year it was less, but that's because of our drought. In a normal year, we have those pop-up summertime thunderstorms that produce hazards. In terms of severe weather, I think we average a marginal risk 25 to 30 days a year. So marginal risk is that 5% chance of damage winds, large hail, tornadoes within 25 miles of your area. We do have a few higher end threats every year, so that day will come this spring. But overall, 140, 160 days a year with storms. Now, let's talk about warnings a little more. Severe thunderstorm warnings, again, that's issued by us here in Nashville. Indications that severe hail and or damaging wind will begin soon. Sometimes we focus on a single storm, like this one, or we have a bigger line of storms and we break it up into sections of the line. We're not allowed to issue warnings for 12 counties or more because then the warning text gets too long on NOAA Weather Radio. That the goal is for weather radio to read that warning in less than 2 minutes. And so if you have 14 different counties in there that it has to go Williamson, Davidson, Rutherford, Wilson, you see it backs up and slows down. Plus there's also a line of storms from Springfield to Nashville to Franklin or something like that. It just really backs up the wording. So we try to break up these warnings for lines into smaller segments. You can also see some of the geographic boundaries playing a role there. This is not actually us clipping the warning at counties, even though that's what it looks like. That's a different forecast area. So we cannot issue a thunderstorm warning into Morristown's area. Sometimes we want to as meteorologists, take care of our neighbors a little bit, but in this case, that's a forecast area boundary. Tornado warnings. Tornado warnings are issued initially when we think a tornado is likely to develop or already occurring. This is an example of a radar indicated warning where we see that rotation. The green means wind blowing towards the radar. Red means wind blowing away from the radar. So you have that rotation right there on the leading edge of the storm. Given the environment, we want to have that instability, that wind shear, that moisture. If it's not all there, we start seeing something like this on radar, we may question it. We may not get too worried, but if it's a day where everything's lining up, we'll go ahead and issue that tornado warning. Then we have radar confirmed that we can have in there. We can also have spotter confirmed, law enforcement confirmed, emergency management confirmed. But radar confirmed, that's what this is. This is actually our Columbia tornado. Big supercell right here. Classic look, that hook echo. That's your tornado, that dot right there. This is our correlation coefficient product. What do you think this is? That's debris. That is people's shingles, fences, maybe part of their house, maybe their car. That's what that is. We were indicating debris up to, I think at the peak of this event, 26,000 feet is how high that debris was going. Now that may have been leaves up that high. That may not be your Ford Explorer 26,000 feet in the air, but either way, that gives us an indication of how powerful that tornado is. If we're only seeing it 5,000 feet and we just had our fall leaf transition and the leaves are on the ground, we may not be too worried about tornado strength, especially if that radar velocity isn't showing that high. But on this day, it had us quite nervous, which led us to issuing a considerable and eventually a catastrophic tag on our warnings. Considerable is when we have fear that this is a powerful tornado. And it comes with wording saying particularly dangerous situation. At 5:45, a confirmed large and extremely dangerous tornado was located near Spring Hill, or 7 miles northeast of Columbia, moving northeast at 30 miles per hour. So we bumped up the tag once we started seeing those debris signatures. Once we saw in our chat the screen capture of the tornado from the Tennessee Valley weather camera at the fire department there before it cut out when they lost power. That was our first glimpse of the tornado. Then once the rotational velocity really ramped up and we started seeing debris 26,000 feet, that's when we made the choice to go to our catastrophic tag, or known to you more commonly as the tornado emergency. So that's when we made this choice here, hazard, deadly tornado, weather spotter confirmed. You are in a life-threatening situation, tornado emergency for northern Murray County, southern Williamson, and southwestern Rutherford. So we made that choice. The tornado didn't quite get there, but based on all the research and our stats, it was showing, hey, there's a decent chance we might get there. So we went ahead and went with that tornado emergency. The last emergency we did before that was December 9th. We started seeing some of the same thing as that tornado was going through Madison and on its way to Sumner County. Quick note about tornado emergencies. So wireless emergency alerts will send that loud, obnoxious tone for just a regular tornado warning for you. But if you get a second alert, that could be the emergency, and it comes with different wording. So if your phone goes off twice, either you've gotten 2 tornado warnings, which we try not to do, or it's that emergency level product. Okay, so the last part of my talk here, what do we need at the Weather Service in terms of reports? We always ask them for reports because that helps us update our warnings. We can go from radar confirmed to confirmed doing damage. So what do we need? What do we not need? First, what do we don't need? Pea-size hail reports. That's not just picking on amateur radio. That's not picking on social media. That's not picking on the general public. It's just a common theme that we have seen. We don't need to know about pea-size hail, the fact that it just started raining. There's a breeze. A breeze is too vague. Like, are we talking 50 miles an hour? Are we talking 30? Is it doing damage? These are the type of things that we want more information on. It's flooding in my backyard. This happens 10 times a year. Okay, we try to limit flash flood warnings to unusual. If this happens 10, 15 times a year, that doesn't really help us. So we also saw one recently. This has been a real bad trend in the weather community, and that's just sharing model data, specifically snowfall. straight from the models. I mean, how many of you have seen big snowstorm coming here next week? Probably a lot of us, right? And the GFS is showing 10 inches across Middle Tennessee. Well, guess what? Our current forecast has hardly any snow, and most of that's going to be tonight, dusting at most. So these models, they vary wildly run to run, okay? So those are the things we're trying to work on. What do we need? We need reports that help us make warning decisions, okay? Maybe we don't have a warning out and you get a quarter-size report, okay? Sometimes pea-size hail is helpful because if we're saying baseballs and you're under the core of the storm and only getting peas, okay, we need to reevaluate that warning. The biggest thing is, are we missing an event? Are we near criteria so that we can have confidence to continue issuing that warning? And damage. So what do we need? We need the what, the when, the where. What type of severe weather is occurring? When did this occur? Maybe that was 30 minutes ago. Maybe it's happening right now. That's a big difference and can really help us figure out where and when on radar that was going on so we can warn for the next group of people. And then where was the severe weather? What do we like to hear about? Hail, flooding in terms of water over roads, abnormal water depths in your community, water that should not be there, ice and snow that can get into helping our emergency management and disaster relief and helping your community, things like that. High winds and wind damage, funnel clouds, and tornadoes. Hail, report the largest size stone that you have compared to common objects. I generally say penny size and larger, although a dime and a penny, there's not much difference there. But the reason I say that is the old severe weather criteria we used to have. We went from pennies to quarters, and we do log this in our storm data, but that is a time when that hail size is getting close to warning criteria, or maybe you're on the edge of the storm, and that can give us confidence that quarters are happening underneath the main storm. How to report severe weather. We have our phone numbers there that you can call us directly if that is quicker. We have social media that we have a great following and get a lot of reports through social media. Since you're a Aries club here, the way we kind of do things in Middle Tennessee is is it district coordinator that we call them? A lot of them we have in our chat service. And they'll feed us reports. Laura is great at feeding us reports during the event there. And so, relay that through your local ham community, and those reports do get to us as well. But these are just a few ways. We have an email, a webmaster email that we get reports through. You can report straight to TV media as well, but I'll tell you the interaction and sharing reports between media and the weather service is not as great because they're usually one person. Like they're trying to do the green screen as well as look at our chat and figure out which channel or which panel they want to flip to for tornado coverage. So they don't have the time to share it back to us, what they get. So that's all I have. I know I went through a lot there. Any questions? Yes, sir. Okay, so...
Repeat the question.
Okay, so his question is, do we have relationships between like weather corporations, private forecasting companies, correct? So there are some there, not necessarily with AccuWeather. We're kind of like rivals, I guess. From their perspective, we're rivals. Because we get into the decision support services and helping events, and that's what they want to do. Like they have products for lightning detection. They have meteorologists that'll call and say a storm's coming. You need to take your safe procedures. But there are weather companies that we do work with. Let's see. One, for example, I won't give you a name, but they're trying to fill some gaps with radars, and we're testing that radar data to see what it can do for us, and helping adjust warnings. There are plenty of other companies that can help us with graphics, that can help us with variety of other things, tools, our internal software that we use, we purchase. So there is some relationship there between businesses, private companies, and the Weather Service. I know personally, I go to weather websites to see local weather instruments. Maybe you have a Davis weather station. I can find that data on, say, Weather Underground or other websites, and I know the type of instrument that is, and the only question is, I don't know how it's cited, so I still have to view the data with a grain of salt, because I don't know if that wind instrument is right next to a house, and therefore that's moderating what's actually being observed. But we do have relationships with business, especially on the research and development kind of side. Okay? Yes, sir.
Follow up on the radar. Every once in a while we'll be watching tracking storms with you guys and support, and you'll see like a pie wedge disappear in the radar screen, and it doesn't disappear on each cast. What causes that drop out in the data?
So there could be a variety of different things. Oh, sorry. Yes, he was asking about, sometimes you'll see a wedge of the radar data missing from our side. It could be other sides. Why is that? There could be a variety of things. Some of it could be beam blockage. So depending on the atmospheric parameters, where that radar beam is, sometimes they could be trees, it can be buildings, cell towers, wind turbines. If you see a lot of high reflectivity around Dodge City, Kansas, or Goodland, Kansas overnight, it's probably a wind farm, So there's a variety of different things that could cause that. Sometimes the radar may be jumping to the next level, and so it cuts off a little too early. But that's a mechanical issue that we try to watch for and correct. But there's a variety of things that could cause that missing beam. Most of the time, though, it's some sort of ground clutter or beam blockage that's probably responsible for it. Now, the storms themselves will also cause data attenuation. So if we have a significant hailstorm between here and Nashville, we'll have what's called a radar spike, a 3-body scatter spike, and it'll show heavy rain over Franklin when your sky may be clear. But that's because of some of the reflection parameters on the hail within the storm itself. So the data is not always the greatest depending on the situation. Most of the time it's very reliable, but there are artifacts that can appear within the data. Yes, sir?
Do you interface at all with the satellites?
Do we interface with the satellites? Yes. We work with NESDIS, things like that. In fact, our next satellite, I think it's GOES-T, GOES-U, something like that's going up. We get satellite data in our office all the time. We get all the GOES data. There is, I think it's a part of our agency, or maybe we partner with them on where to position the satellites on a given day. So not the satellite itself, but like where we're actually capturing data from frequently. We have mesoscale sectors that we can get a picture every minute. Most of the time we get a full scan of the United States every 5 minutes, but we can get more data. So we do work with that and try to put those mesoscale areas that best suit the US needs, okay? So in the morning, that satellite may be focused on San Francisco Bay Area for commerce and aviation traffic with the fog and stratus. And then the afternoon, they flip it over to, say, Oklahoma for severe storms. So we can move those around depending on the needs too. Yes, sir?
Does AI get used by the SPC or you? Or?
We're still in its infancy. Sorry. Does artificial intelligence get used by the Weather Service? Yes. Part of it we've been doing this for a little while, not in terms of like making its own decisions, but we have bias corrections for our model data that interpret like how our forecasts have done the past 30 days. and corrects that. So if we're consistently low on our high temperatures, eventually our bias corrections will catch up and start providing us guidance of higher, 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 like say during a drought in the summer. So we've been using it in that capacity, but in terms of like having it just spit out the forecast for us and all the interpretation services, not really yet. Thankfully, our field right now is still in a stage that we have to have the human element to interpret, and that may be more where we go into these decision support services. I will say right now the Weather Service is looking at days 4 through 7, and if every local office needs to be doing those forecast grids, or could the Weather Prediction Center in Maryland do that, we would still have the days 1 through 3 when we're making the watch warning type decisions. But we're looking into things like that to account for these new technologies and make us a more efficient agency.
One more question?
John got one.
Yes, sir.
Is there one person, or are you all jointly responsible for the humorous Facebook posts that show up from time to time that are wonderful?
Okay, the question is about our Facebook posts. I got you this time. And who's doing those humorous posts, okay? We do have one person that is extremely creative and really good about the lyric post. We try to limit this towards more like your calm weather days. Sometimes we wiggle it into our weather event type briefings. For example, I was actually the one that did the recent Ice Ice Baby post, if you saw that ahead of our freezing rain event, because I knew that would get people's attention and it would get shared. And what do you know? We had well over 1,000 shares, well over 1,000 interactions, like 700 comments. So a lot of us can do that, but there's definitely one person that's by far and away the most creative at our office. And he's very good about keeping that social media interest, you know, and people do come to us not just for a little entertainment, but they know it's a reliable source of weather information. Okay?
Ryan, thank you. Let's have a round of applause for